Hello, everyone. We can maybe wait for a few minutes and then start. Yeah. In the meantime, if you have any questions, you can feel free to ask. Yeah. Okay. There's a question about return by value and return by reference. Okay, sure. I think I can cover that first today. Sure, sure. Okay, awesome. I think we can start. Uh, Short recap, and then I guess I can take the question first. So, right. Last week we saw uh, something about arrays. Okay, so let's start with arrays. So essentially, it's like a list, and I hope I'm audible and my screen is visible. Okay, good. So right. So last time we saw arrays. So array is like also a form of list. It's a data structure uh, of list. And yeah, it's a question. So, but one thing to be careful here is array are stack allocated. So this is an example how to define such class like this data structure in and use them in C++. The other thing we saw were this was a 1D array. Okay, this is a C++ style array, and this is a C style array. Same functionality, but the idea is it represents the same data structure, but you get more functionalities and more functions and member functions because it's now a class. So it's more useful to have a standard array. And like that's the thing. The second thing we saw is having 2D arrays. So essentially the idea is you can have ND array. So here we saw a 1D array, a 2D array, a 3D array, and so on. In these are C style arrays. Then you can work with them as such. And important thing to note here is in C++, the or C, in like C, you can think in general in C like languages, the ordering goes is more like row column major. Okay, row major format. So we have columns and rows if you have matrices. So it's more like it's a row major format. Okay. Now, thing to remember here is essentially like from the right hand side to the leftmost, you get the fastest index ordering. So if I have something like ij, j will be the fastest index. Okay, so in a way you can think like since 5 and 3 are the sizes. So 5 is one dimension of is size of one dimension, 3 is size of another dimension. 3 get the size with the dimension with this 3. So as in the second dimension, it gets filled first, then the 5. In B, it is straightforward because it's just one dimension. In C, it will go from the rightmost to the left. Okay. So to illustrate that, I wrote a simple code where I'm filling values from 0 to, let's say the total size is 15. So the values will be filled from 0 to 15 and in the order in which they are actually arranged in memory. Okay. So because my J index is here and I have an I index here, I'm making J as the fastest index. And if you write a code like this, you can actually show, I mean, you can print and see for yourself also that you get numbers in according to the order of indices. Okay, you can just print around the things and then get the same answer. In standard array, you do not have such a 2D array or ND array because essentially the idea is that the memory layout will be a single flattened array. So you can just have a flattened array and then write the same thing. Okay. Next, we saw about const. Const is a qualifier where you, if you define it for some kind of way, for some value, integer or double or anything, the idea is that that variable cannot be changed later in the program. So to illustrate that, I took various examples with addresses and pointers. Next is using heap. So this is a way of using allocating memory in on the heap, right? So so for that you use new, the keyword new. This is from C++. You can also use malloc, but that will be that's is sort of like equivalent to malloc in C. But you should be familiar with new because it's the C++ way of doing things. Okay. The same heap, it's like essentially allocating a certain block of memory on the RAM or on the heap. Okay. So, but if you want to use data structure which already takes care of all these things, then we use vectors. Okay. A standard vector, and then I showcased how you can use the. I doubt about this too. What's placement new? How's it different from new? Uh, Placement new. Okay. Is that a different keyword? I guess this is also like new, but different pool of memory. I see. Okay. Haven't looked at the lectures. Mostly, I just cover some certain topics I uh, believe and find interesting. I'll just take a look. Sure. Um, okay. So one example will be like you create a buffer using this character string. So it's pre-allocated, and then point the pointer to the new buffer string hi placement new. I see. So essentially, what I can see is it's mostly they say when you want to create. So essentially, what happens is when you use the new keyword, the you actually allocate memory. You're asking for memory, and the program will try to determine that has to okay where I can give the programmer some certain amount of memory. But I guess the idea behind placement new is that it's more of an optimization thing where let's say you want to create multiple instances of an object. So you can actually create new instances of an object using new operator. Uh, so it's faster to not reallocate memory each time. So for a new instance, this is more of an optimization thing when you want to repeat same allocation for multiple objects. So that's what I see in the description. It has a garbage collector. Okay, that is new. As in different from new. Actually, the only new. In general, if you use new, sorry, yeah, is that a question? Okay. So if you use new, you have to use delete because this is more of a user managed memory, and a more clean or clear way of handling data would be to use the new keyword and then just delete it. Okay. So that is on the part of the programmer to manually allocate and deallocate. When you use this placement new operator, apparently the garbage collection already exists and you don't have to worry. So that is the thing. You don't need to deallocate every time. Yeah, that's the difference. Okay. So essentially, you're using the new keyword to allocate a buffer, and then use that buffer to create more other examples. I do not have examples here, but I guess you sort of get the idea. Mm, maybe can write a program and see that. Okay. Yes. Normally, oh yeah, yeah. Be careful here. Normally, when we use new keyword, the default behavior is new is user managed. You have to delete after you are done with whatever pointer it's pointing to. Okay, that is the default behavior. With the placement new, it's a I don't see where from what standard it was introduced, but this is more of a next level. Okay, like on top of this actual new. Okay, let's write a code and see. But in general, you have to do this because just using new to allocate some kind of memory, you have to delete it. Okay. So because the reason is that when you use new, you are actually uh, asking the operating system or whatever managed environment for certain amount of memory. After the code is done, it's actually the responsibility of the user to deallocate that memory. Especially when we use uh, function or not functions, keywords or like functionalities of C++ like new. Okay. All of this is automatically taken care of if you use vectors. Okay. Because once the variable like B or C here goes out of scope, the destructor is called and the memory gets reallocated. Okay. So one example I see here is this. Okay, so new, then characters, let's say size of standard string. So this is a pre-allocated buffer. Then let's say we make this will require standard string. The pointer p also to new, then use that buff itself, and then on a string, and then define what we want. So something like, let's say hello. This is the pre-placement, the not pre-placement, sorry, the placement name new. And yeah, to contrast, if one does this standard string, let's say pointer q as new and standard string, say hello. Okay, this is just a ordinary name or ordinary heap allocation. So let's look at the ordinary thingy first. It's essentially the similar to the one I wrote here. So you define it's a new operator, but what do you want to actually define? So for example, here it's new standard string hello. So standard string of hello is created, okay, with new keyword. So the allocation becomes heap allocated. So that is the heap allocation. It's the ordinary way of doing it because you do new, give the data like the type, whatever you want to initialize, create a new sort of like an allocation or object of it. And because it will return a pointer, the pointer to that is what we're storing in queue. And its data type will be standard string pointer. So that is the data type you see here. The difference is that when between Q and P is we create P, but with a buffer. The buffer is already like created with the character string, okay, with the new as character of size of strings. Okay, so you already create that buffer and use that buffer to create new anytime any new string. Okay, this is the placement new operator. I hope the difference is sort of slightly clear now. There is this new, which just creates uh, like some object of standard string hello, which this also does, but we actually say how much data because standard string is already a sort of data type that we know. I mean, C++ knows. We give the um, we give we give the hello word, right? The characters. Then standard string already knows how much it has to allocate. We use the new keyword. Then now we make sure that this is heap allocated because we have used the new keyword. There's a return type for standard string with Q, right? So hence the pointer. Next, you want to use placement operator, placement new, then we do this. Okay. So I hope that is clear. I'll come to the other question about return by value and return by reference. Okay, sure. Okay, great. Awesome. Next, yeah, okay, maybe let's do return by value and return by reference, right? Um, might as I would like to rephrase that and just talk about a concept called pass by reference, as in maybe it- cover it in reference itself. Yeah. Okay. Awesome. Right. Okay. Let's start. So let's have IO stream. Now let's deal with just vectors. They're convenient. I think will actually make the point across also. So sure. Let's work with vectors. First, let me define a vector. Okay. A of size, let's say 10. Don't forget to templatize. So when I say the question mark, it has to be the data type of the vector. Let's go with integers for now. Not a problem. Now what I'll do is I'll write a function called function, okay, and pass a. Okay. Now how does my this function look like? So this function is itself a void, okay. So there's no return type or anything. And inside it takes vector, okay, a with template. So just to make it consistent, I'm making it integer a, template of standard vector template a integer, and it takes something like, okay, I don't need to write it as a, I can make it as b also. Okay. Now what we will do in this is make a for loop, give it I0, I is less than p dot size, okay, then I plus plus, okay. Next, what we'll do is fill this vector pi equals to I. Okay, I think this ought to be. I'll just repeat what I'm trying to do here. I'll just return 0. That's just to complete the main function. That's all. What I'm trying to get at here is we declare a vector A of some size, okay, pass that vector to some function and define that function as such, where the standard vector integer b, like I'm naming this as some b. So essentially the function func takes input of this data type, which is standard vector int, okay, and the name of that parameter that it takes is b. Okay, it's just an input parameter. Now, what we're trying to do here is write a for loop where it takes the size till the size of it, okay, of I, like the I runs from till size of b, and we just fill that vector. This b is a vector, right? Okay, that's all. It's a very simple code. Okay, just do it. Next, what we'll do is try to print this. We'll do the same thing. Okay, but instead here we'll print the a because a is what we have defined. B is here. Okay, this is very important for the function itself. B is the scope of that function. As in, B is a parameter, input parameter. You can call it any name actually. Okay, so what you're passing here A, you can actually name it A here, but they won't be the same. They need not, I would rather say, they need not be the same object or the same actual variable. Okay, let's think of them as simple variables also, but the idea still is the same. They're not, they need not be the same thing. Okay, it's actually what I'm trying to, the point I want you to come across. So there is something called a b input parameter on which this function works. Okay, the function gets the input a, okay, and then after the input, we're trying to print this. Okay. Awesome. So let's compile and see the program. That should be reference. Yeah. Awesome. So I compiled and ran the code. As you can see, all the values are 0. Okay. Can anybody tell me why? This was expected actually. Okay, so what happened here is the A was created. It's not like this wasn't created. Okay. And initially, when you create any object, the default behavior of standard vector is that it stores value 0. It's not exactly initialized. So technically speaking, when you have this is actually, so we'll come to class and constructor and other things today. But when you, this is actually a class. And when you initialize, like you actually declare the class, and this is and pass 10, like here to giving the size. So its initial constructor is called. And the default behavior is that in standard vectors and such, it sets those values to 0. Okay. Now, because of that, all the values, all the 10 values inside A are 0 already. Function A, when it's called, we pass A by value. Okay. So here the pass is actually like passing to that function is happening by value. So here the thing to note here is when you pass A, it creates a copy of A. Okay, it's not the same object. It creates a copy of A and calls it B. Okay, fills the whole thing because this is the loop. And as soon as this goes, the function goes out of scope, it destroys B. So effectively, here passing function A doesn't really do anything. So if I have this function or not, really doesn't matter, because if I print those after initializing A, I print A, like the values of A, I still get 0. So you can actually check that. Still 0. Calling this function doesn't really do anything because we're passing A by value. But I just add one letter here. So this ampersand actually represents reference. Okay. Then what magic does it do? Now we see it all, the values change. The reason for that is here uh, the A, the standard vector, when passed to the function fun, it is passed by reference. So the difference between having this and not having this is this line of code means a pass by value. Whenever you see a pass by value, it's a copy. So when A is passed and the function sees this line, what it does is it creates a standard vector V as a copy of A. Okay. There's a question of is it same like we used in C to pass an array as an argument of a function? Yes. So my question is it similar to pass reference? Yes, exactly. Yes, it is. It is. So essentially, there are you can think of it like three ways of passing any data. So one is this pass by value. The second is pass by reference, and the third one is pass by pointer. I mean, as in, it's not exactly called pass by pointer. You're actually just passing the pointer. Okay. Essentially, one can think of it like there are actually only two ways of passing to a function. It's either by value or by reference. Okay. I'll showcase the pointer also, but it is actually also passed by value. But yeah, let's make this thing clear first. In C or C++, both have the same functionality. Both actually mean so you either pass by value or you pass by reference. Next, so this is a pass by value where it sees the function A. Okay, it has some size 10. Okay, awesome. It has size A. So when it creates B, it takes A as the input for its constructor. We'll come to classes and objects, but essentially what I'm trying to get the point across is B is empty. It is just a standard vector. It doesn't have any size allocation or anything. But when it sees A, it will mimic its size. Okay, create a vector, okay, of size 10, and then gets filled here. Okay, so if we and I will check that print the size of B. So you see the size is printed as 10. How does it even know what will be the size? It's the default behavior where if you pass A, it creates, and now this is the pass by value, right? So it creates a copy of A. When I say a copy of A, it's not the exact same object, but all the properties it has will just get copied. Okay. By that, what I mean is it's already allocated, right? So it will just create another another vector of the same size, something like that. Okay. Gets filled. Okay. Awesome. But the problem is for function func, okay, the B data structure is actually just in this scope. So as soon as it prints this guy and reaches this scope, it just destroys it. The function gets, in a way, what no, someone is asking about. So yeah, the question originally asked about return, right? So here there is function returns. So this void. So there's no return, but you can think of like null return. So the function returns, but A wasn't touched. A lot of things happened with B. Allocation data was filled and deallocation happened, but then nothing. And then when we print A, it's all zero. Okay. Now okay. I hope this part of pass by value is clear. Okay. Now let's look at pass by reference. When I put something like this, essentially you can think of like any data type, okay, with operator like ampersand. Usually ampersand is there's a question also, why did I did not get it. Also, why did yeah, I'll maybe talk about the reference then. Okay, yeah. So group ending for, oh yeah. So normally you don't need to if you have just one line. It's definitely good practice to have it always. But if you have just one line in the loop, so a for loop ending with just a semicolon, if it's just one line in the, you can actually avoid parentheses. This is true for if statements, else, for loops, or any other. Yeah, I hope that doubt is clear. In reference, will it change the value assigned to the exactly? So that's the thing about reference. Let's look at that more carefully. So this ampersand symbol has meaning according to where you're using it. So we saw in const, here it means address. So ampersand of a variable, when you use it in this context, it means address. Okay. Here also, address of P, address of N, and storing it in N. And what is N? N is some pointer. So a pointer stores an address. So address of M is stored in N. Okay. And N, we define it as an integer pointer. Awesome. I hope this idea is clear. Keep it in the back of your mind. But ampersand, when used in context like this as a function parameter, okay, like an input parameter or something, with some custom data type or any data type, actually, you can have integer ampersand also here. Here, specifically, ampersand means reference. And what does that mean? When you pass, okay, sorry, my bad. Well, to do this, yeah. So when I pass A here, this is a standard vector, etc. A pass by reference ensures that A and B are the same thing. By that, I mean they're exactly the same object. Memory, even to down to the memory, actual memory they take. So for function func to access data structures outside it, like A, it doesn't know A exists. But when I pass by reference, it knows something called a B. Okay. Now here's the funny thing, that something called B is exactly the same A. Now it's just start working on it. Okay. So always remember, in actual physical memory, if you see the actual code, there will be just A. Actually, B will not even exist. It'll just, um, for our convenience, we're just making it B, but B doesn't even exist. As in, there is no such separate B or anything. It's the same A. I hope this distinction is more clear, because when you pass by value, you're actually creating a more distinct object. Like it has its own memory allocation, it has its own memory size, etc., etc. But when you pass by reference, it is actually exactly the same object, down to the memory allocation, like down to the where this function is actually stored. Okay. Now here the nice thing happens is when we pass A by reference and print it, so now it prints exactly the values. And see, here it prints from A side. So what happened here is A went in, actually got changed because it is the same B, because when we're trying to change A, it is A which is actually being changed. Okay. And B dot size is actually printing A dot size, which is 10, and then print is, and so on, right? The nice thing about passing by reference is you're not unnecessarily allocating or deallocating memory if you want to actually change that value. Okay. Now, um, this is good because already because the object is created, memory is already allocated. All that function can do is, like, the better way to do is just fill the value and end it. So this is the difference between pass by value and pass by reference. You can even do a pass by pointer, but that's essentially pass by value only, but works as a pass by reference. I'll show what I mean. So let's create integer pointer. Call it maybe uh, um, p. Yeah. Next, we'll write a loop. Here I have to pass the size. I am going to, okay, just pass something called size also. Okay. And then use that size here. All right. Next, the p. So remember, with the bracket operator is essentially a dereference operator. Okay. We saw that previously in pointers where, okay, I did not probably cover this as a recap, but I hope you get the idea. Pointers have, like, this is essentially a pointer, right? So the there are two ways to dereference. So dereference is actually accessing the value present at the pointer. Okay. Essentially, pointer is an address, and address stores some values in units. Okay. And now that unit will be of some data type, like integer or something. To access them, there are two ways. The first is this bracket operator. This is a dereference operator, or you can do arithmetic with A, as in A has some address. You can shift it with some value, dereference it with the pointer, this star operator. This is also dereferencing the pointer, and store it or access it or whatever. So I'm just doing the same thing. Access P, okay, and then store I. Good. So another thing here is I'm just overloading this function, as in depending on the input, we'll call the corresponding function. Okay. I can actually comment this and call something like this, a dot data. So this is a useful function of vectors that you can actually access the raw pointer of it by calling the dot data. Essentially, a dot data is some integer pointer. Okay, so that's what is being passed. I also need the size. So I'll just pass a dot size. Okay, now we pass these two values by value. Important. So it passes the pointer by value. And what does a pointer have? Address, right? So if I pass the pointer here, it creates. Think of a dot data as some q or something. Okay, it's some pointer. It copies the value to p. Okay, but what got copied? It's the address. So when I try to change the address, it actually essentially works as working with a reference. It actually goes and changes the actual address, but you actually, when you try to pass pointers, it also creates a copy. Okay, so essentially, but the copy, what happened was just the initial address was passed. That's all. So it's not very expensive also because it's all happens in stack and all. So performance wise, not much difference between passing pointers or passing by reference. But when you pass by copy, then you get in trouble. Okay. I mean, you can have genuine reasons to pass by values in other, like the other case we saw, but again, depends on the problem. Okay, so this loop fills pi, okay, and that's it. I think we can then just print the value. Okay, yeah, as you see, it prints from 0 to 9. Okay, 10 values. So that this is the way you can pass something by value. This is also like pass by value or pass by reference. Okay, for completeness sake, I'll just leave it like this and remove the ampersand. Okay, nice. Okay, awesome. So I guess the distinction is clear between pass by value and pass by reference. Essentially the same idea. Return by value, when you do, you can have the standard. So in this case, actually, something like this. So, okay, awesome. Uh, right. So if you have something like this, which is a pass by value, sorry, it's a pass by value, you can actually have a return. So what you do is you just do return of this data type. Okay. So here function expects a return of standard vector integer type. So you can actually then do is return B instead of just no nothing. You can just return B and put something like this. Expects, so you can probably, I don't know if this will give you segfault or some other weird errors, but in general, actually what you can then do is not pass anything, or maybe pass a size. Okay, that is fine. No, let me not call it a dot size. That is bad. I'll just call it size, uh, and then define integer. So we'll reverse the thinking a bit and see from not from passing, but from return. Actually, that was the original question. So to build up to that, now let's look at this portion. So we'll define a size integer, size as 10, pass that size to function. Okay. So I define my function in that sense. So there is function which takes integer size, that's what I'm passing, and setting it to A, because that is the return type. Okay. So essentially what happens is here size is defined. So I can do one other thing is, sorry about that, vector, okay, integer B and the size. Just pass the size for the constructor. So it takes the size and I can just dynamically create B, fill it, and then return. Okay. So this is another way of returning B. Again, B here gets destroyed, but because you're setting A equal to B, it creates a copy of B to A. So A becomes the copy. And I need another line here. My bad. Oh yeah, I can either do it two-way. So declare A first and then do this, or I can just declare it in the same line. Okay. And then try to print A and see if it does anything. Okay. Actually, can check now. Does pass by value retain the actual values? Yes, it does. When it creates a copy, it copies the values also. So we filled B here and returned B. B got destroyed because, well, out of scope. B is here, it's inside the scope. So B gets destroyed, but it returns B here. So it copies to A, and now A is a copy with the size 10, right? Because B had the original size 10, and the values also get copied. Okay. So this is return by value. Yeah. Actually, no return by reference because, well, there is no return actually. It's the same guy, same value. So yeah. Oh wait, actually there is return by reference as in you can do it this way. Yeah. So B gets, oh yeah. And let's say question, sir, which will be faster? I mean, earlier we used ampersand B and here we are returning a whole vector. Yes, absolutely. So depends on the problem, because if you think about it, okay, previously pass that, and the function only did is writing something by reference because it was passed by reference. I just wrote that function and that's it. And I printed it and entered my program. So before the function, so essentially in the whole program, one allocation was done and one delay allocation was done at the end of the program. Start the program, there was the allocation, and function here, if you see this function, it just changed the values. That's all. In this example also, okay, you are declaring something A, okay, as function. So if you let's break it down, like from performance perspective. So if you have a function inside it, this we actually allocated memory, filled it, then return. But then B gets destroyed. So the allocation happens for B, allocation and deallocation. But there's a copy also happens, which means another allocation of memory and then deallocation. So we actually do it twice. So in general, yes, pass by reference is what is very commonly used. Okay. And that is something, if used correctly, and well, mostly likely you'll use it correctly, is pretty fast. I would say it's one of the fastest way of doing this thing. Okay. So if I'm returning a vector, whole vector, so the problem isn't if I'm returning a vector. Now I'll show an example. I'm returning a vector which is as like, because pass by reference. There's more or less no difference. But because we pass a vector by value, this is, as in return by value, we're creating a copy. And that means another allocation. Okay, that is slower. But if I have a pass by a return by reference like this, so I'm returning the vector B itself. Okay, this might actually create some issues, but let's see. And so what I'll do is something like this. Create A, take it as a reference from function func, and then read. Let's see. I hope this is not. Yeah, it. The problem, you can actually return by reference. Mm, small problem here is that B will get deallocated because here it's in this stack of in the scope of A. But let's assume it doesn't get deallocated. Okay, there are ways to work around with this. I'll leave it as an exercise. So think of this way. So if I return B and let's suppose here it doesn't get deallocated. The allocation was already done, filling was done. So I just returned B, okay, and named it in the main function as A and worked on it. So in keeping in mind that it doesn't get B actually doesn't get allocated, you can also get the same performance as passing by reference. Okay. I hope this example is clear. Okay. I think we need another loop in main for copying B in A. You actually don't. So if you have something like this, so you're returning B here, and this is standard vector. The standard vector automatically will make a copy for you. It's there in the standard itself. The code is there. You don't need a loop for it. No. Okay. I hope that is clear. Let's remove this. So we saw function taking some sizes, passing by value, passing by reference. Okay. So this was for maybe I'll write it. Return by value. Awesome. This is pass value. This is pass by reference. Generally, I'm um, uh, partial towards passing by reference because correct pointer, and are you accessing the address or the pointer real reference and all. It takes care of all that, so you don't have to worry. So usually I just prefer reference. They're cleaner also, so that's all. Okay, there's a question about didn't understand the need of use of reference in return. Oh yeah, sometimes. Oh, okay. So yeah, okay. So it's the use case. Let me think of an example. So generally what we do is, let's say it's more clear in passes and like classes and objects. Sometimes you can create an object of another class and pass that object as a reference to some other class. So then you can actually call that same object by some other name in another class and work on it. And you don't have to worry about allocation, deallocation, or creating another object or anything. This code will still work if reference is removed. And why is it was it used? Oh, no, no. So it sorry. So return by reference actually it is just to show you how you can do it. But a more concrete example I can show you when we go to class and objects. This is what I'm saying. Okay. Uh, Maybe I'll show the return by reference in that example. Okay. But I hope the idea behind this specific example, I can't do a return by reference because B gets deallocated. So it doesn't make any sense to um, actually return B as a reference. I hope you understand. Okay. So I understand there are questions about return by reference. I'll showcase that actually in class and objects. Okay. I hope this is clear. These ideas. Okay. Yeah, that's correct. In return by reference, you are returning the first hash digit memory. Well, let's just call it the address. Okay. So not even that. So what actually happens is when you return. So I understand the natural way of thinking. If you see ampersand, you just think about address. It's not exactly true. When you see ampersand, it depends on the context. So in cases of pointers and like example here it means the address. Okay. You can never think that you're returning the address here just for understanding. But if you see the actual compilation, when the code, when G++, the compiler actually sees the whole code, if it sees a pass, like return by reference or pass by reference, like in this case, it will make sure that here the assembly code actually refers to the same memory. As in, if it uses internal variable for B, it will use the same internal variable for A. Like for A, whatever it uses, it will use the same for B. That's all. Okay. So that is the actual thing. But if you want to understand by just thinking of it like passing by addresses, it is not from understanding perspective and what the code actually does. It's okay, but it's not exactly that. Okay. So passing by reference essentially means that the code internally, whatever it calls A, will call B the same thing. As in, it will not create any other new name for it. It will point to the same exact address. It will point to the same locations and everything. That's it. Okay. Right. Okay. Moving on. Okay. So previously, I think we saw const, right? Okay, got it. So what we can see today is the inline function. Okay. So hash include string. Okay. Then let's add some simple function. Like let's say Just add text input X and Y. Okay. And returns. Okay, these are all just integers. So I'll just return X and Y. Okay. Now this is a simple function. I'll call this in main. Define let's say A equals to 7. Integer B equals to let's say 4. Okay. And integer C equals add function. Okay, I'll call that function and pass A and B to it. This is a very straightforward, simple code. Okay. Maybe I'll this and print C. Okay. Now, don't think I missed anything. String is there. Okay. So let's. I hope this code is clear. It essentially just I declare two variables and declare two variables, pass it to add function, and then just print it. Okay. I know it's a simple function, but it will get clear on that. Okay. That's done. Yeah. Awesome. So expected output was 7 plus 4, obviously. It's 11. But what I want to uh, make clear here is this. You can do the same thing using something called a macro. Okay. You can hash define, let's say, add macro, where it takes things like X and Y. Okay. And the what it replaces it with is X plus Y. So the nice thing about this macro is it doesn't really care about the data types. It assumes that X and Y are the same data type and there is an operator plus which can operate on them. So I can do it this way also. So something like this and use that macro AAB. Difference is that this inline function can only work with, I mean, it is a good example for templates later, but so here this add function which I have written can only work with integers because it can only accept X as integer, X as Y, Y as the integer, return something which also has to be integer because this is the written data type. With, let me just comment that, but with macros, you don't have to worry about that because it essentially what this line does is it sees add with some input parameters like this and replaces the whole thing with X plus Y. It took X and Y, replaces with X plus Y. It took A and B, it will replace this. It's a preprocessor. Before even compilation happens, a preprocessor will just replace this line with X plus Y, or in this case, A plus B. So integer C is A plus B. Again, the nice thing is it doesn't care about the data type. Now, this is the dangerous thing as we talked about macros before, so use them sparingly. Can we do that locally? Oh yeah, you can do it. I mean, essentially, this was done by with a function. You can do it locally. It's a simple function, but uh, addition is just an example here. Here to showcase this macros and later on the next inline functions is why I do this. But yeah, you can do them absolutely locally. It's actually the inspiration behind inline. So now let's see that. So hash defined, but the reason again, oh yeah. So what I was saying is when you use macros, you have to be very careful because they're preprocessors. Even before compilation of the code actually happens, preprocessor comes into action. So debugging that can be very tricky, and one has to be very careful while using preprocessors like macros like this. But the good thing is that there's actually a difference between calling by function and using just a macro, because if you have a function, it has, let's say, a line like this, and say, for example, you're calling that function many times, there's actually an overhead to calling a function itself. Okay. You have to pass A and B. It will copy to X and Y. Okay. Right. We saw the pass by value. Actually, pass by value happens. So it creates a copy of A and B to X and Y. Calls this function. There is a that itself has an overhead also. Then it adds them and returns. So this function call itself has an overhead. To avoid that overhead, one can do it this way. Again, the macro has another good property where what it essentially does is it just replaces this A and B with A plus B. To showcase this, I'm just using a plus example. You can obviously do it locally also, but sometimes you can have little more complicated functions than this, and you do not want to uh, write that here. Okay, and you want it to work as a function also. Okay, now how to do that in C++? Because we want to avoid macros. In that case, you use something called an inline function. You use the keyword like declaration as inline. Okay, define that function as inline, and then when you do add a b, what this code will do is it will take the body of uh, add, okay, x plus y, paste it here. Essentially what a macro would do, but better in the sense you're actually not using a macro. Okay, so the problem and other things that comes with macros, the preprocessor and all, we don't have to worry. Okay, code doesn't essentially change, but now because of inline, the body just gets copied here, just like a macro. Okay, so we just print now. Yeah, 11. I mean, the answer won't change in either case, but the um, main thing is that we're getting the functionality of a macro in C++. Actually, macros are from C era, but with advantages of using a macro. Hence, we use an inline. Okay, I hope this is clear. That was the idea behind macros. Okay, there's a question. Can you use macro in a condition option? Yes, yes. You can use. Generally, I would say avoid it. Only use. I mean, I in modern C++, as this is the course. In modern C++, there are a lot of changes and lot more functionalities has been added in C++, where you can actually avoid a lot of macros. So you might remember the hash defines, like this hash defines something to this, right? You can have an inline function for that. Sometimes people have macros to compile a code, right? So before the preprocessor compilation happens, you have a preprocessor directive where only a portion of the code gets compiled or not. You can have this if else conditional. Sure, an example, right? Um, I hope I don't make mistake. Let's see. So as if then, yeah, uh, then has defined, right? Uh, I thought it will see. Macros. So we usually use it for very specific cases. Hash defines need to be defined. So let me just think of an example. Mm, Events become not even check. Yeah, I guess that is also okay. Just have a return and then check. So, okay, I'll complete this part actually. So hash defines macros, right? So you can, okay. So let's say there is a define. I'll just give it a rough code itself. if something isn't defined, okay, and it gets called, so you can define a piece of code. Okay, I'll put all of this in comment for now because this won't get compiled, but just to illustrate an idea rather than just saying it. So you define some code. So this is the code here. Okay. Then uh, there should be some kind of else. Okay. Whatever macro equivalent is. Then you end the if def. Okay. So some other code. So essentially what I'm trying to get at here is if this condition gets satisfied, there's some conditional. Okay. Usually it is macros are usually written something like this. So you use underscores and then define something like this. Okay. Uh, macro, let's call it. And there are reasons to that because otherwise the problem with macro is again the reason why it's suggested not to use more as in use it sparingly. So macros are for the whole program. You can have like huge codes, right? And if a macro which is used in some other library that you're linking to, and let's say the same macro you're using in your library, that macro can get overwritten. Problem is, compiler won't even know if it was done. So it can't even throw errors for you. So that problem happens, right? So it's another reason to avoid macros. But let's say you have code like this where if some conditional is satisfied, then this code gets compiled, else this code gets compiled. This is another good thing about macros. Again, that if it's let's say this uh, part is get it's true and it compiles this portion of the code one, let's call it, and code two. You can the good thing is because code two will never get compiled. Okay, if you have macros which true or false and correspondingly, you can have very nice code actually, as in you can have certain definitions which would have actually thrown error if maybe if both were simultaneously true or something like that. If you actually don't want this code to compile when this is true or something like that, right? So in those cases, macros are very useful, but there is a C++ also has an equivalent called the if const expression. This is, as you see, it's much complicated looking thing, right? So you can just use if const expression and pass the conditional here. Best part, it works exactly like if else. So your code one goes here, code two goes here, and you can put up brackets appropriately. Yeah, it essentially works like how you write in C++. We'll see. I think const expression later, but this is much cleaner, and it works exactly how this macro would have worked. Okay, so this code only gets compiled, code one, if the conditional is true, and it doesn't even matter if code two has some other problem. Like let's basically it doesn't have to uh, compile both of them together. The question about is single lambda expression. No, it is not. So what so lambda expressions will also learn. They are essentially functions without a name. It's like you don't want to explicitly name a function and call it or something. So lambda functions are on the fly. You can think of it like nameless on the fly functions, which actually gets compiled. What I'm calling it here is you actually can have lambda functions inside this code one and code two also. Okay. What I'm talking about here is if const expressions, if some condition is true or false, depending on that, a big region of a code can get compiled or not. Let's say I have code one where uh, something like this, let's say. Inside this, I have a void function, okay, which mm, takes input parameter A. Okay. And this code 2 also takes input parameter B. Same function. If the problem is when these two cannot exist together if you think about it, because there is a function definition collision. Same data type, same name, same inputs. How does the compiler know which to actually access? But let's just say that for some reason you want the function to be exactly the same in two regions, but with different body. Okay, it has some different bodies here, depending on the condition which function you want. Now here, this will definitely work with constant expression, because if this is true, then this portion gets compiled and this whole code just gets ignored. Okay, like a comment you can think of. And if it's false, then this portion of the code gets ignored. That's all. People used to achieve the same thing using macros, but C++, I think from C++ 11 or 17, I forget which standard, but if const expressions are available. Okay, awesome. Another thing is, if whenever you use const expressions, they have to be compiled and constant, which would have happened for macros also. So again, that consistency is maintained. Okay, this is a much cleaner way of determining which portion of the code you want to compile or not. Yeah. Okay. All right. So moving on. Mm, oh, hello. Okay. Right. Next, what we can see is, okay, I'll start. Um, okay, before starting another, is there any questions before until now? I hope the idea behind inline function is clear. Essentially, it is like you have a function add, it takes the body, copies it to this line, wherever you're calling that inline function. There is force inline also, where essentially the idea is that inline is more of a suggestion to the compiler to please copy the body here. It may not listen to you, so you can have a force inline. Okay, so it actually has to do it. So you can see performance differences depending on which thing you do. Yeah, here it's a very simple code with express. So just to showcase, I just these examples I wrote it. It can be a little more complicated. Okay. Yeah, that's all. Okay, any questions before I start the next thing? Awesome. Okay, let's start a very important topic in C++, which is called object-oriented programming. There was a comment in the chat about lambda expressions. Those fall under actually functional programming. Okay, so there are two paradigms of programming. One is object-oriented, another is functional programming. C++ actually provides both. So depending on how you want to approach your code, you can do one of them, like either of them or both. Absolutely okay. Okay, so let's look at classes now. The main thing behind object-oriented programming. Okay, yeah. Right. Do I get that here? Right. Okay. Yeah, that's fine. The function, the file exists. So I'll include the IR string as usual. We want to print stuff, so let's let that be there. We'll define something called a class. Simple. It's uh, the keyword that starts any class. We'll define something called complex. Okay. And we'll look at each of the portions individually, but let me just write something first. We'll define something called double, real, and imaginary. Image. Okay. Then yeah, I think for now let it be this way. Yeah. Next, I'll define the main. Okay. Before that, okay, let's keep it here. No, okay, maybe declare an object and then we'll proceed. So something like this. Mm, 2.0 maybe, sure. Okay. So I wrote a bunch of code. What does this even all this mean? Okay. Essentially, there is a concept in C++ called classes and objects. Okay. So first of all, what's a class? A class is essentially a template, as in not the template that we see as in vector template. This is the template. It's actually a C++ template. But what I mean here when I say classes, it's like um, a sort of a formula, a sort of a uh, in the generic sense of template as to what that class means. So for example, here when I say a class of a complex, I want to define in general complex numbers using a template. Okay. As in I and what does a complex number have? It has a real value, it has an imaginary value. Okay. So I can define any complex number using just these two values. Excuse me. Yeah. So if I so just give me a second. Yeah. Okay. So essentially what a complex number does is, as in if I want to define a complex number, oh yeah, this is a question. I'll come to that. So uh, I have something called a complex class. Okay. So I'll use that to define any complex number ever, sort of. So, and each of these values I'll represent with some double real or double imaginary. Now, this uh, way there is a construct, there's a functionality in C++ to do the same. That's what a class is. A class has a name. So here I'm this complex word itself. Okay, this text itself is the name of the class. Okay, and it has members. So double real. Okay, real the word the text real the variable itself is a member. Okay, it's of data type double. There's another data type of data type double member called image. So that's the imaginary part. So I'll use these two numbers to represent a complex number. Now you can think of uh, classes as a custom data type. We saw before here vectors, right? So like standard vector in some namespace standard. Okay. Okay. The way we see this one in some namespace standard. Okay. Yeah, maybe see this guy actually. So in some namespace standard, ignore the template for now, but this is actually a vector, and so it's like an instance. I'm specifically making an object, okay, which will, and that object here is C1. The good thing about that object is it will have its own real variable. It will have its own imaginary variable. How do I make sure that happens? Now, while constructing that C1, I can just pass some values for it to construct. There is a thing called constructor. I'm not written it here, but it will use something called a default constructor. Essentially, what's happening is we'll take the values 1 and 2, okay, and store in this. And there's a question in the chat which asks, how do we know which variable is assigned and all? Okay, so it goes in the order of encounter. So you might think that declaring variables like this actually is fine. You can define imaginary first and real later. Technically, yes, but if you think about stack allocation, real gets defined first and then imaginary. Okay, so here, because of the default behavior of these classes in modern standards of C++, one gets the real, the first allocation, and two goes to the second one. Okay. So let's, I hope this doesn't throw an error though. Yeah. I hope this portion is clear. I'll repeat it again. So I declared something called a complex number C1 because I'll declare more, but you can think of like complex number C itself as a template, as in, oh, okay, it's a better word, blueprint. Okay, there's a blueprint for complex where double real is one member, imaginary is another member, okay, and C is the object. How do I declare it? I pass the values like this, okay. You can also declare it this way, okay. It's absolutely okay. This is another way of declaring the same thing. I'm declaring this way now. Okay. So yeah, right. Uh, okay. So it is clear, right? Then there's this word called public. So what happens in public is the variables that are defined, the member functions that are, or member variables or member functions, or you can have functions also, whichever is defined in public can be accessed outside that, uh, as in outside that variable, outside that object. What I mean is, if I try to access real defined under C1, so I can do it this way. Okay. So this is the actually accessing the value stored inside real under C1 object. Similarly, okay, I can maybe just print this. Let's do that. Okay. And okay. And similarly, let's do that for imaginary. Okay. Now formatted, done. Okay. Let's print 1 and 2. Great. So because we declared it this way, and one was stored for real, two was stored for imaginary. Hence, when we try to print it, we get this. We can also create more complex numbers like 2. Let's say this is 6, this 7, complex number 3.2. This is 10.4. Yeah. Similarly, then we can just print all of them. Okay. Here will be 2, then 3, so on. So now I can just compile and print. We'll print all the values correspondingly. Okay. The nice thing about, like, why do we use this? Like, now imagine I had to make many complex numbers. Here I made 3, but if I have to make many complex numbers, I would have to. It will be very difficult to keep track. As in, if here it's a bit simple here. Okay, maybe I'll give another example and then thing called norm. Okay, it doesn't need to take any value because all the values we require are already here. Okay, so um, that should be okay. Yeah, that's fine. Okay. That's good. So we return something called real times real, okay, plus image times image. So essentially, I'm taking the L2 now. Okay. So the two norm of the so complex numbers themselves are like a vector, right? So its distance from origin is real square plus imaginary square. And if I take the square root of it, okay, okay, and return that same thing, okay, that'll give me the norm. Now, the good thing is, because I have a blueprint of complex number, I can define some stuff like norms inside the template itself, inside the blueprint itself. And if I want to just if I call let's say the norm, okay, function, I don't need to call the function and pass its member variables and all that. It'll internally automatically do it because all this function itself is a member of this class. And for a given object, it will calculate its own norm correspondingly, as you can see now. That's the beauty about using classes and objects, okay? Because each object has each object follows a blueprint, but has its own values for those members. Okay, and correspondingly, it can use its own um, values, right? These internal members for corresponding functions even, right? So what I can do is I can just call c1 dot norm, and that's it. So this is a member variable. It's a member function. Okay. I'll combine this. Yeah. Now this should be C2. This is C1. Sorry. So if we start printing, okay, there's some errors. Oh, lot of errors. Uh, my bad. I missed the operator. Awesome. So as you can see, I'll clear this and print again. As you can see, the imaginary and real parts, real and imaginary parts are printed for one C1, which we know what it is. But I don't need to actually create this norm function as a separate function and then pass these real values and imaginary values, so on. If I just call the norm function on of C1 correspondingly, it will just give me the norm. Okay, so that is what is the beauty about using blueprints. You can define a certain blueprint and call different objects of it with different instantiations. So when I say instantiation, it is essentially giving it a value, okay, and constructing it. So there's no constructor we have written yet. We'll maybe see that next or in the next class, depending on how much time we have. But the idea is that the default constructor takes these values, creates this object, okay, and a very nice thing. Once this C1 itself, again, it's an object, right? So it goes out of scope for main, the destructor gets called. Here, there's a default destructor, yes, which will deallocate all this memory for member functions and member variables and clean up the data. Okay, that is the main use case behind uh, classes and objects. Oh yeah, so chat has a question, how can I use square root without header math? So essentially, there are certain header files which uh, compilers like GCC or G++, they will include it anyway. Okay, so square root is, I think, defined on the CMath or something that is by default included. You don't have to explicitly include. Yeah. Okay, I hope that is clear. Let's look at more examples. So I guess this part about class and object is clear, right? Any questions? Okay. Right. Let's make another class called line. We know, um, oh, my bad, sorry. But- So we know line is a collection of points, right? And complex number itself also is a point. So actually, technically, it's a vector, but let's um, let's make a line now. So okay, think of it like a line segment. Yeah, rather than a line, think of a line segment where the endpoints are themselves represented by complex numbers. So imagine two complex numbers, and the line connecting them is what we'll define. Okay, using a class now. Yeah, that idea is better. Yeah. So let's actually include string, and let's copy this function. We have class, right? Now we have the complex class now. We'll define something like line, class line. Okay. Very important. Class has to end with a semicolon. The function, the class definition itself, all the body and everything has to end with a semicolon. Done. Next, we'll define something complex itself. Okay, we'll use the complex um, data type as in. Okay, think of if you see here, the complex name itself for the class becomes the data type. Okay, that you can think of it like a custom data type. Okay, instead of just data types like integer, double, and so on, you can have custom data types which you can use to construct objects like C1, C2, C3, and so on. Okay. Now, let's define a class called line, and then line itself will have two complex numbers, right? The A and B. So let's call it A and B. There are two complex numbers, A and B, which represent the end of the line, as in the two ends of the line segment. Okay. Next, what you can then do is define uh, uh, first two objects for the complex number. Complex, let's say 0.1 p is we can probably use this again. Sorry, excuse me. Yeah. So let's use these. But this time I'll just call them P1, P2. 2 points, right? Next, since I defined P1 line, which takes two inputs, two complex numbers, so I can define something like line. Let's call it L1 as taking P1 and P2. Okay. Now, yeah. In general, I mean, I can also define something like this. So this is one way of defining this class called line, right? So what I'm doing is I'm passing an object P1 and another object P2 here. Can anybody tell what is this specifically as in pass by? I'll give the whole code here. This is passing the objects P1 and P2 to line. Maybe format it for better looking. Yes, passing object as a parameter. Yes. More specifically, it's pass by value. Okay. So we saw before pass by value and pass by reference. So P1 and P2 themselves exist, yes, but for line L1, when we pass P1 and P2 as two complex custom data types, it copies the values to A and B. It will have its own A and B, yes, but it'll create a copy of it. Okay. Also, we can define the line 2 as such. So you can define like, let's say 0.0. Okay. Yeah, okay. Well, let's make a rectangle. Let's say. So so 1.0. Okay. Now let's make this as origin. Then 1.0, 0.0. Okay, this is the x-axis, the first lowermost thing. Then maybe let's call this L0. So that I can start with L1. Then if I want to make L2, which is the next segment, so 1, 0, then 1 and 1. Okay, next, the next line, L3. Start with 1.11. What's an object as pointer? Yes, 1. 1011 0010 00. Let's make it this way. 01 and 11. Okay. Last one, not least. The 00 and 01. Okay. You can check that this actually forms a complete rectangle. So 00 to 10, then 10 to 11, the 00 to 1. Okay. So question, are we reassigning the value of P1, P2 here? No, we're not. So essentially what's happening is we're creating different objects of line, okay, called L1, L from L0, L1, L2, L3, sorry, L4. All right. So all these are different objects, okay, each having its own input A and B, which themselves are also custom. As in, there is no overwriting of P1, P2. Here I created P1, I created P2. So P1 and P2 exist in memory. And they were used to create L0 because I passed them. I passed P1, P2. So P1 as a complex number exists. P1, P2 as a complex number exists. L0 as an line class exists. But for L1 till L4, all this I'm actually manually just giving the values. So all these values, L1's A and B, and L1's A, L1's real, L1 B's real and imaginary, and so on. Okay. P1 has the real part, P2 has a imaginary, real imaginary, P1 has a real imaginary, P2 has a real imaginary, L0 has A and B, okay, which themselves have a real imaginary, and so on for L1 till L4. Okay. I hope the distinction is clear. This is a different way of doing the same thing, but I'm not explicitly defining these coordinates. Okay. I really don't need to because L1, I can access all of these coordinates from L1's members, which themselves are members, are objects, so they have their own members. Okay, so you can actually do something like L1 dot A dot real and do any combination. Okay, do B is real. Okay, A is imaginary, so on. Imaginary. I hope the idea is clear. Okay, I'm not going to print this, but I hope you can convince that you will get corresponding values. Okay, some other question. The data type of parameter of the line is complex. Yes, that is what is important. It has to be complex. And the good thing is here it can actually take these values. I mean, ideally you should construct it and then pass or something, as in it will not work always. Yes, but it's just another way I'm showing which works. Yes, but ideally, yes, ideally you have to pass complex numbers. This is a very simple and crude way of writing things, which I did. Actually, I should make it public. Okay. Um, sorry about that. one should ideally actually write the constructor, okay, and then call these functions, okay, like this. There is a more cleaner way of doing it. This is what I'm showcasing to just make sure things are. This is one another way of writing things. That's all. That's all. Okay. Then maybe I'll show only the next part so that how actual class. So this is just to understand what are classes, but one can uh, one uh, deals with classes in much more complete form. So let's see that complete form. Class, let's say to class. Okay, or maybe I'll call it just what it is, constructor. We see actually it. We see a class with here. Whenever you see a class, it has a constructor. Okay, so if you don't explicitly define it, which we are going to do now, there is a thing called default constructor, which will use it to set things appropriately. Okay, but let's write that constructor for now. Stream class complex and okay. Next, okay. What we what we saw where and this is important. Constructor has to be public because any guesses why? Yes, very good. So that can be accessed from main or any other function. But the main idea is that construct because they are called outside of from not from the internal of that object, but from outside. Because now when you declare an object, you have to construct it. Like you have to call its default constructor or its custom constructor what we're writing. If constructor itself is not public, then how can one even call it, right? How can one even initialize anything? So that's very important. So let me write it this way. So real, it takes two parameters, real and imaginary. Okay. But if you notice what I'm doing is I'm writing it with underscore to showcase that I'll have variables, right? Uh, real and imaginary as the actual members, and these are the parameters that it takes. Okay. Just to make a distinction, I'm putting an underscore. That's all. Next. So this is what a constructor looks like. Okay. And yeah, so one way in C++ you can define things is you can set something real equals to 4, right? So let's say you can also do it this way, real 5. Okay. So the other way of thinking it is this real takes 5 as its value for its construction. Okay, maybe this will be more clear if I do it this way. Yeah. So I define two members, real and imaginary. Okay. Now, because real is defined, so I can use real and it's a double. Okay. So in C++, you can think of it this way. Even the custom data types have classes that we're writing a constructor now. Even the inbuilt data types, you can treat them like a constructor, have their own construction. So I can just pass to real, this real, okay, the parameter that is being passed. Okay. So it will construct, it will set in a way construct this real, which is the internal data member of complex. Similarly, I can do this way also, imaginary, okay, and set imaginary to that. So complex taking some input parameters separated by like a colon, setting values, okay. This is essentially all part of the constructor. Okay. You can have even a body, right? And I'll just maybe make a statement like with print saying that constructor called for class complex. Okay, next. And okay, and I will end my function. Yes, there is a destructor also. Let's just completely write that. So it starts with this tilde uh, operator. Okay, so complex, and then you can just leave it with empty body. So it will automatically use the default destructor. It's basically I do not want to define it, so I'm just writing it this way. Right. So yeah, why not? Let's complete the full class. So we had the double also. So let's make that. Okay. So we define the norm, right? Inside public. So double is public now. Complex constructor is has to be public. So we made it public. Complex destructor, constructor, destructor, both public. Now we want to call outside. So again, public. And yeah, oh, there's a getter and setter. Oh yeah. So getter and setter functions, essentially the idea behind them is, yeah, we use them in mostly um, the classes and objects. This is a setter in a way. You can think like we're not exactly writing a setter. We're just declaring the setting the internal variables. You can have setter functions. We can actually see that maybe in next class. Getter and setter functions. So getter function will be if I write something to get this real value. Okay, here getter function is useful because can somebody tell me what these values are, real and imaginary? As in, I don't write it inside public, so by default they become private. Okay, so now to access this real and imaginary because before I had them inside public, right? I could do this c1.real, but what about now? Let's write in main uh, complex. C is uh, 0.0 with 1.0. Now, can I call real and maybe print it? Real C real is online. Okay. So I mean this is a valid code, sure, but will this work? Let's find out. So this is construct. Good. That's clear error. Can anybody okay, already the compiler says it. The okay, maybe I'll give someone chance to can ask someone. So can you tell me why this threw an error? Why can't I access c.real? The be careful looking at this line. This double and real is not declared inside public. After we do declare public, we define complex. Okay, we define the destructor, we define the norm, but we did not define them in real. They're private. Yes, exactly. So by default, if you do not provide anything, okay, so in C++, the members become private. You can explicitly say private, which is I would say it's a good practice to do, so that there's no confusion. But yeah, it's up to you. You can here in this place you can omit or not. That's the thing. Now, important thing is because I can't access. Oh, my bad. Sorry. Here there is a um, right now. Now, okay, compilation. Barring the compilation, now this should not throw error for compilation. Like, if I want to access real, right? I now I can write a getter function. So it's like this. Get real. Okay, if I just call that function, this should just return me real. That's it. So instead of calling c.real, I'll call c.getReal. So now this will return the real part, okay, of the internal variable. access to real. Okay. And I have access to get real because it's public. Right. So this is actually a getter function. Okay. You can have a setter function also, set real. Remember here the construction, when actually construction happened, it took real and imaginary, okay, and then constructed the comps number C. You can actually manually set later on using some double, okay, real, I'll just call it underscore real, where real equals underscore real. This is a setter function. Okay. It's, I think the idea is not, idea is clear. It's not very complicated. Okay. A getter function gets the member variables when they're private. A setter function sets them when they're private. That's all. And we do them through functions which themselves are public. Okay, that's all. Now this should work. Constructor real. Mhm. Did I miss something? I did not pass. Wait, oh wait. Okay, maybe it's repeat. Oh, there's a return type. Sorry. It doesn't require any return type. But constructor was constructor called for class template, right? That happens because when this line gets called 923, the constructor for the class gets called. Okay, it sets the values and everything, 0, 0, 1, 0, and everything. When we call the get real, it prints the real value, which is 0. Okay. I hope this part is clear. Okay, now I'll go to the questions. Can we invoke default constructor? Yes, you can have a default constructor, but the problem is here I actually defined a constructor. Okay, it's like a custom defined constructor. So you cannot do C and then just bracket. This will not work. For this to work, we have to actually overload this constructor, okay, to take no so here this experts what do you call those input parameters, right? So if you do not pass anything, you have to actually overload them, right? And write a default, write a corresponding constructor for them. So that is the answer to the question. They're private, yes, that was the thing. The type of line is complex, yes, that was answered. So I can maximize, yes, getter function, yes, getter function. Can we invoke, I think that I answered just now. Line 7, we are doing the same, right? Okay, Aman, line 7, when you say which piece of the code here, I actually probably changed a lot of things. So line 8. Yeah, what do you mean by that when you say we're doing the same thing? If you define one constructor, will the default constructor also exist? Oh yeah, so no, it doesn't. Then you have to actually write for every type of constructor. So here, when I wrote a constructor, it was actually work. It would work for this kind of definition. As I said, if you just give C with like empty brackets, something, it won't work here. We have to uh, correspondingly define an overloaded constructor. Yeah. Yeah. The value real equal to real isn't it setter? Yeah. So slight difference. When we say a setter function, it means we want to call it or do it multiple times. Thing about constructor is it happens only once when the object gets created. So yes, you are correct that these values get set for the real and imaginary private, the member variables, but that only happens during the construction. Let's say I want to set it later again. then I have to create another object. But if let's say I want to change the this real and imaginary for the same object, C, I need to have some means to access that, right? So hence the setter function. Okay, I hope that out is clear. Okay. So here the setter function sets this real part. It doesn't need to, it just needs to be a void function. That's all. It's fine. Awesome. Awesome. Okay. Uh, so as good as time to end the class, I questions if you have any doubts. But this is what I would like to cover for today. Yeah. Any questions? Any further questions? Oh yeah. Why use for class name for main? Oh yeah, a good question. Because main is a function, class is not. Class is its own thing. Class is a custom data type. It has its own rules and definitions. So class is actually beyond. It covers functions also. So double norm, right? So double norm with a scope. It in itself is a function, right? With some data type or return type or something. And this is enclosed within something called a class. To enclose the class, we use a semicolon to end it. But if you think about it, main is itself a function. Yes, it's an overloaded function. You can, but you can have arguments that you can pass while compilation itself. So yeah, main is a special function though. Yes, I don't disagree there. But yeah, that is the main difference. Yes, there you go. Return 0. Okay, question. If there is default parameter, then it is correct code complexity to invoke constructor. If there is default parameter, then it is yes. So uh, correct. So if I want to have like let's say complex C, right, and just end it, here it probably will throw error, right? As you can see, it doesn't recognize it something. But if let me comment this um, constructor and destructor itself. Okay. So now I have and relying on this C++ standards constructor, default constructor, for me to construct these two guys. Let's see. It still throws an error, yes, because it 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 cannot. Yeah, as I understand. To invoke compiler, yeah. So you can actually test it out. We saw that this works because it takes these values and sets them for private members. But the default constructor probably is clueless what to do with just C. As in, if you think, yeah, write only constructor. Yeah. Oh, for that. Yeah, sure, sure. I can write a construct for that. But if I rely on just the default constructor to make this line piece of code work, okay, it has a real and imaginary. It sets them to some random like values, right? So if you don't set a variable when it's initialized, it's not necessarily it has to be 0. It can have some garbage value like we saw now. Okay. So here I'm relying on the the constructor, okay, the default constructor to construct this complex number. Again, I can rely on the same to construct, but here the extra thing is that the default constructor will set these values. Okay, so we can see that. Wait, something happened. Mm, yeah, here I have to actually write the constructor. Okay, so anyway, one we can then do is complex. As the question is asked, we can just give it this and real. Okay, I'll give it 0 and image as 0 and just leave the bottom empty. Or I can just put the whole thing again. Why not? So this is an overloaded default overloaded constructor for that, which takes no parameters but sets them to some default values. Yeah. Include C include brackets with the object. Oh, okay. While calling the object. Okay, sure. I think it should work. Let's see. Mm, okay. Let's not worry about that function for now. Go step by step. I think it requires a destructor also. Yeah. Do I have the constructor? Yes. Declaration. Yes. Declare a variable. Yeah. It doesn't take variable. Then yeah, that is true. Mm, then what we can then do is maybe do it this way. I hope this works. No, it expects yeah, that's what we expect it to work. I mean, as in I use the default constructor for it. Let's see. Should throw. Okay, that is fine. Did not take any values because the constructor is written to not take anything, and it set the real and imaginary to zero. So I hope this should work now. Okay, zero. Great. Awesome. So the values for real and imaginary were set to zero for this case, for this constructor, and a sort of a corresponding declaration was done. We set the values here, right? And when we call the get real function, it returns the real part, which was set to zero. Okay. So question about, I hope Ritik, that doubt is clear. Aman has a question, if the object of class, okay, is not created, okay, how compiler will treat with class did even assign heap. Okay, there is, okay, the first question is, if the class is not, if the object of class is not created, okay. So technically speaking, uh, yeah, there's a distinction one has to do. So when you, okay, I think this is a good example to see. Even if you're declaring custom object, right? Like a custom with a custom class, this C, when you're declaring this, still a constructor is created. It's called. Okay. So if it has internal functions which get called, let's say here in this definition, I just print a constructor was called, but actually I can have heap allocation or stack allocation or anything. So inside the constructor itself you can have some allocations. So technically speaking, uh, will from the construction of the class itself, you can have some kind of allocation, is what I'm trying to get at. Okay. But I think that your question asks if the object of the class is not created, okay, how compiler will treat with class, will it even assign heap? So if you mean assigning the object to some heap or stack, then kind of yes, because even if I don't, if I just declare class, it used some constructor. So this C gets stack allocated. Okay. Okay, sure. Uh, actually, I'm not supposed to discuss assignment questions, but well, then again, it was a doubt, so I think that's okay. Even I have no idea if this was an assignment question. So anyway, even if I didn't instantiate the object, yes. So uh, that is, yeah, that is the thing here. Ideally, this is just a declaration of the object. Should not be an instantiation, but it will happen here because we wrote the class as such that as such. Okay, because the class is written to have a constructor of this sort. So if you don't instantiate the object, yes, you are right. If you don't instantiate the object, none of these private variables or anything will get created. As in, okay, no, okay. What I mean to say is, mm, uh, there, okay, So this real, this imaginary, its own functions and everything. Okay. Schedule of the class, it's every week, every Tuesday from 6 to 8. Yeah. So this is mostly just to get your doubts clear, and I'll probably cover some topics to just have like refresher or something. So that is the goal of this live lectures. Classes will be actually from the NPTEL course that you're taking. So you can go through those lectures. Uh, for another thing, I'll probably mention, should definitely mention, is you can ask questions in this class, but since these are weekly, to get your doubts clear faster, you can definitely post your questions in the forum. It is regularly monitored. So if you want to get your doubts cleared much faster, so there you can ask them. Yeah. Yeah. So the question was about assigning memory. Yeah, that's the thing. So unless a constructor gets called, memory is not assigned, is what I'm getting at. So, and there is always sort of a default constructor that gets called. So this private variables and everything, they sort of exist always, like the blueprint always exists if you have a object created. Yeah. Okay. I think I got all the doubts. Okay. Awesome. Awesome. Thank you. Thank you, everyone. I think we can end the class here. Yeah. So waste of memory. Yeah. Kind of. Yeah. So mm, this is how do I put it? Mm, think of it like the template exists for the memory to get created, but it's not created yet. Yeah, that is the that's what I would say. As in, it's sort of like declaring a vector class. Okay, let's actually take this example. Mm, because vector is also a class. So if we declare a vector like this, it's uh, how do I put it? The object was created, yes. It has its own size variable, which will return 0. Okay, so the size variable, the function, there was memory, there will be memory little small also, so not a problem. But the actual memory of the values are not there because the size is 0. When you actually resize the function and then put values, then yes, you're actually giving it memory, and that will be much larger. To be fair, when you declare classes like this here, okay, maybe here, this one, standard vector has its own set of functions and some internal variables. Okay, yes, it's a static class, but if you think about it, the actual memory comes from, like, if I compare with the internal variables compared to the actual memory that it will probably ever take, that will come from its resize, as in the size of that function. If I, let's say this is 1 billion list, that is the one that will actually take the memory, and all the internal things, which is like dot size or dot capacity or dot data, even for accessing that pointer, right? Technically, yes, they also take memory. Functions themselves also take memory, but not as much. Yeah. Okay. Okay. Awesome. I guess we can end the class here. Thank you everyone for joining, and do practice. Yeah. Thank you. Thank you everyone. My advice would be definitely do practice, as in do questions so that you understand these concepts better. And again, you can ask questions in the forum itself also. So yeah, to take advantage of that, do the assignments, definitely submit them so that you actually learn. And programming is the best way to learn is actually writing the code itself and running it. Compiler gives you a lot of uh, errors and other mistakes that you might do. So that's there. And debugging itself is an art. So the more you practice, the more you get better at it, right? Okay, awesome. Thank you everyone, and happy coding. I will see you guys next week also. Yeah.